On this field trip, we are going to Cotopaxi Volcano in the Ecuadorian portion of the Andes mountain range. The Andes, the longest continental mountain range in the world, extend the length of the western edge of South America. They are a continental volcanic arc created as a result of the subduction of the Nazca Plate beneath the South American Plate. In the north of this range lies Ecuador. Ecuador's official name is La República del Ecuador, or the Republic of the Equator. Here at Mitad del Mundo, the middle of the world, the equator is running right below us. We're just north of Quito, Ecuador's capital. We'll be traveling to Cotopaxi Volcano, about 50 miles to the south. Approaching Cotopaxi, we drive through the village of Santa Rita. The people here live just 10 miles from the vent of the volcano. Villages like this one dot the landscape around the volcano. From here, it's a short drive up into Cotopaxi National Park. Cotopaxi is a classic composite volcano built through dozens of large eruptions from a central vent over the past 20,000 years. It is an active volcano and always has the potential for eruption. Even now, you can see steam rising from its vent. We are high in the Andes. The summit of the mountain is over 19,000 feet above sea level. That is more than 4,000 feet higher than any of the peaks in the Colorado Rockies. Here, on the north side of the volcano, we're able to learn about its history and potential for future hazards by studying the volcanic rock deposits from recent eruptions. Strongly explosive eruptions are typical of composite volcanoes. During its history of many large eruptions, Cotopaxi has produced layer upon layer of many different types of deposits. By carefully studying these deposits here in the field, we know what these eruptions were like. This is what field geology is all about. Reading the rocks that have been left by geologic processes in order to understand what has been happening here through the past.
Okay, let's take a look around. These green hills that you see here are made from deposits of pyroclastic flows from older eruptions. This gray flat area here in front of us with all of the large boulders on top of it is the deposit of a lahar flow from an eruption in 1877. A lahar is created when hot ash is erupting out of the top of the volcano. It's melting the snow and ice on the summit, and a mixture of water and ash comes flowing down the valleys on all sides of the volcano. This slurry, like a wet cement, flows through and carries large boulders with it. In 1877, the lahar flow that came through here continued following river valleys all the way down, making it to the Pacific Ocean 200 miles away in only 18 hours. These lahars are the biggest hazard from eruptions in Cotopaxi. In Ecuador, there are many villages, towns, and cities that are built upon the river valleys that these lahars can flow through. You remember the settlement of Santa Rita that we drove through on the way up. The lahars have the power to carry away and cover everything in their path. Okay, next, let's take a look down in this canyon and see if we can have a closer look at the lahars and the pyroclastic flow deposits.
Here we are in a small canyon where the layers of erupted deposits have been cut by erosion along a small stream during recent decades. This allows us to take a close look at the makeup of these deposits and to study their differences.
Here on this side of the canyon, we have a large wall which shows us a cross-section of the lahar deposits that we were looking at from above just a minute ago. This allows us to see what the lahar is made up of. When these lahars were flowing through the valleys in 1877, they were carrying thousands of tons of rock and mud. You can see we have an unsorted mix of very large boulders down to very small material. And in this case, the lahar deposit is at least 20 feet thick, as we can see on the outcrop. Okay, here on this side of the canyon, we have this pink wall of rock, which was created from a pyroclastic flow deposit. This is a different kind of eruptive deposit. 5,000 years ago, an eruption from Cotopaxi volcano sent a cloud of hot ash and gas screaming across the landscape to here and beyond. We can tell this is a different type of deposit from the lahar because the internal structure and texture are different. We have very fine ash and pieces of pumice, and we have some internal layering. Once this material was deposited, it was hot, and so it welded somewhat to form a rock called an ignimbrite. So first, 5,000 years ago, we had the deposit of this ignimbrite. Then, in 1877, the eruption from Cotopaxi caused the lahars to come flowing down the valleys, up against this cliff and around and beyond. And in the 140 years since then, we've had erosion which has resulted from the water flowing through this stream. So here in the field, we can interpret both what kinds of eruptions and what kinds of flows and deposits have come through. We can also interpret the order of events, so we can say something about the history of eruptions from Cotopaxi volcano. Looking over toward this older eroded volcano, Sinchalawa, you see in the front many small rounded hills. These hummocks were formed during a debris avalanche. When we have an eruption of a composite volcano, it's possible for large sections of the flank of the volcano to break and slide as a debris flow. The reason for this is the shaking and the deformation of the mountain that's associated with magma rising up into the volcano. These hills were formed during an eruption of Cotopaxi when a debris flow came down the flanks of Cotopaxi, across the landscape, and started going up the flanks of Sinchalawa until they were being slowed and eventually stopped by gravity, forming these many distinct small hills.
Driving closer to the peak of the volcano, we can see that part of the mountain was cut away during this road's construction. This road cut reveals layers formed by material ejected into the air during multiple explosive eruptions throughout the history of the volcano. Large blasts can cover the entire region in ash and lapilli tephra that falls from the sky. Layers of ash from past eruptions of Cotopaxi can be found over 100 miles away. This hidden history of past eruptions revealed by the road cut is a vivid reminder of the hazardous nature of active volcanoes. Given its eruptive potential, it is important to monitor Cotopaxi for any signs of activity. Let's go look at one example of this work. Scientists from the Geophysical Institute of Ecuador have positioned monitoring stations all around the volcano. This equipment measures seismic activity, surface deformation of the mountain, gas emissions, temperatures, and more. The data is transmitted in real time back to the Geophysical Institute in Quito, our last stop, where we'll meet Dr. Benjamin Bernard, a volcanologist at the Institute.
Welcome. Here we are at the Geophysical Institute. More precisely, we are in the monitoring room of the Geophysical Institute. So the objective here is to collect all the data that come from stations installed on the volcanoes, different kind of stations that helps us understand what is going on with the volcanoes, and give information to the authorities and to the population about potential threat due to this volcanic activity. So you can see all the screens. We collect seismic information, ground deformation. We also monitor volcanic gas to have a full picture of the volcanic activity.
Cotopaxi is an active volcano. It last erupted in 2015, sending plumes of ash and steam a mile into the sky. There will be a much larger eruption at some point. We don't know when this eruption will occur, only that it will happen again. Cotopaxi is just one of many active volcanoes scientists monitor in Ecuador. Determining the potential for hazardous eruptions is only possible when we understand the eruptive history of the volcanoes. This history is uncovered by going into the field to study the rock deposits that were created by the eruptions throughout the life of each volcano.